In 1950, a mathematician named Alan Turing asked one of the most important questions in human history: can machines think? That question launched a revolution, one that took decades of bold ideas, frustrating setbacks, and relentless persistence from pioneers like Geoffrey Hinton, Jan LeCun, and Yoshua Bengio. And now, that revolution has arrived in your classroom, your workplace, your living room, and your pocket. Welcome to Teaching and Learning with Artificial Intelligence, the podcast for educators, students, and lifelong learners who want to understand one of the most transformative technologies ever built and use it wisely. Every episode, we explore what AI really is, not the science fiction version, not the hype, not the fear, but the real, documented, evidence-based story of what AI can do, what it can't, and what it means for the people who teach and learn every day. We'll trace AI's history from the earliest algorithms to today's large language models. We'll tour the platforms reshaping classrooms around the world. We'll ask the hard questions about plagiarism, critical thinking, privacy, and equity. And we'll look ahead at where this technology is taking us and the choices we still get to make. Because here's what we believe: AI is the great equalizer when it's done right. A student in a rural school deserves the same personalized support as a student with a private tutor. An English learner at a community college deserves feedback at midnight, not just during office hours. A first-generation college student deserves the tools that have always helped the privileged get ahead. AI can help make that possible, but only if we understand it, only if we use it critically, and only if we insist that it serves everyone, not just some. Whether you're a teacher trying to figure out what to do about ChatGPT in your classroom, a student wondering how to use AI without losing your own voice, a policymaker shaping the next generation of education standards, or simply a curious human being living in a world reshaped by machines, this podcast is for you. Teaching and learning with artificial intelligence. Let's figure this out together.
Chapter 2. The Pioneers, from Turing to Deep Learning. Key vocabulary: neural network. A computing system modeled after the human brain structure, consisting of interconnected nodes that process and transmit information. The neural network, trained on millions of medical images, became better at detecting certain cancers than experienced radiologists in controlled studies. Deep learning. A subset of machine learning that uses multi-layered neural networks to analyze and learn from large amounts of data. Deep learning enabled the development of facial recognition systems that are now used in security applications around the world. Perceptron. One of the earliest artificial neural network models, developed in the 1950s, designed to recognize patterns and make simple decisions. Frank Rosenblatt's perceptron was a groundbreaking invention that demonstrated a machine could be trained to classify objects by adjusting internal weights. Backpropagation. a training algorithm used in neural networks that adjusts the weights of connections based on the error between predicted and actual outputs. The development of backpropagation in the 1980s was a critical milestone that made training multi-layered neural networks practical and efficient. ImageNet, a large visual database designed for use in visual object recognition research, containing millions of labeled images across thousands of categories. When a deep learning model achieved record-breaking accuracy on the ImageNet competition in 2012, it signaled a new era of AI capability. Feature article: Standing on the Shoulders of Giants, the Visionaries Who Built Modern AI. Every technology has its heroes, the visionaries who persist when others give up, who imagine possibilities before the tools exist to realize them. The story of artificial intelligence is rich with such figures, and their contributions continue to shape the tools teachers and students use every day. Alan Turing, 1912 to 1954, is rightly called the father of computer science and AI. His 1936 theoretical paper introduced the concept of a universal computing machine. His 1950 paper, Computing Machinery and Intelligence, posed the famous question about machine thinking and proposed the imitation game, later called the Turing test, as a measure of artificial intelligence. Turing's vision was far ahead of its time, and his tragic death robbed the world of decades of further genius. John McCarthy, 1927 to 2011, carried the torch forward. Beyond coining the term artificial intelligence, McCarthy invented Lisp, one of the earliest and most influential programming languages for AI research. He also pioneered the concept of time-sharing computers, which made computing accessible to more people. Marvin Minsky, 1927 to 2016, co-founder of the MIT Artificial Intelligence Laboratory, contributed foundational theories about how minds, both human and artificial, represent knowledge and solve problems. His work on perceptrons and frame theory shaped generations of AI research. Frank Rosenblatt, 1928 to 1971, introduced the perceptron in 1958, a landmark device that could learn from experience by adjusting weights in response to feedback. Though Minsky and Papert later published a critique that temporarily stalled neural network research, the perceptron's conceptual descendants now power modern AI. Geoffrey Hinton, Yann LeCun, and Yoshua Bengio, often called the godfathers of deep learning, were awarded the 2018 Turing Award for their decades of work on neural networks. Hinton's development of backpropagation, LeCun's convolutional neural networks for image processing, and Bengio's work on deep architectures and language models laid the essential groundwork for today's AI revolution. Their persistence through multiple AI winters, when most researchers had abandoned neural networks, is one of the great stories of scientific dedication. The 2012 AlexNet breakthrough, developed by Hinton's student Alex Krzyzewski, used a deep convolutional neural network to smash records on the ImageNet challenge, correctly classifying millions of images with unprecedented accuracy. This moment is widely regarded as the spark that ignited the modern AI era. For educators, these pioneers offer powerful lessons beyond technology. They demonstrate intellectual courage, the value of interdisciplinary thinking, and the importance of long-term investment in research. Their stories can inspire students to persist in the face of failure and to pursue bold ideas even when conventional wisdom says they cannot succeed. Review questions and answers. Question 1. What contributions did Alan Turing make to the field of artificial intelligence? Answer. Alan Turing proposed the theoretical framework for universal computing machines, posed the fundamental question of whether machines could think, and designed the Turing test as an early measure of machine intelligence. His foundational ideas established the intellectual basis for computer science and AI. Question 2. Who are the godfathers of deep learning, and why are they significant? Answer. Geoffrey Hinton, Yann LeCun, and Yoshua Bengio are known as the godfathers of deep learning. They won the 2018 Turing Award for their decades of work developing neural network architectures, backpropagation, and deep learning techniques that now underpin most modern AI systems. Question 3. What was the AlexNet breakthrough, and why was it important? Answer. AlexNet was a deep convolutional neural network developed in 2012 that dramatically outperformed competing systems on the ImageNet image recognition challenge. It demonstrated the power of deep learning at scale and is widely considered the event that launched the modern AI era. Question 4. Why did neural network research stall after the perceptron era? Answer. Research stalled largely because of a 1969 book by Minsky and Papert that identified mathematical limitations of single-layer perceptrons. This convinced many researchers to abandon neural networks for other approaches, delaying progress for years until deeper architectures and better training algorithms were developed. Question 5. What lessons can students and educators draw from the lives of AI pioneers? Answer. The lives of AI pioneers illustrate the importance of intellectual persistence, interdisciplinary thinking, and long-term commitment to ideas that may not show immediate results. Researchers like Hinton, LeCun, and Bengio continued working on neural networks through periods when the field had little support, ultimately producing transformative breakthroughs.
That's our episode for this week. Thank you for thinking alongside us today. Every conversation on this podcast starts from one belief: that understanding artificial intelligence isn't just for engineers and executives. It's for every teacher standing in front of a classroom, every student staring at a blank page, every parent trying to make sense of a world that changed faster than anyone expected. AI will not replace great teachers. It will not replace human creativity, human empathy, or human judgment, but it will, and already does, change the conditions in which all of those things happen. And the people who shape those conditions are the people who understand what they're working with. That's why we're here. That's why you're here. Before you go, we have one ask. Take something from today's episode into your classroom, your school, your community, or your own quiet reflection. Ask a question you hadn't thought to ask before. Share a tool with a colleague who needs it. Challenge an assumption, including one of ours. The future of AI in education isn't written in code. It's written in the choices that educators, learners, and citizens make every day. You are one of those people. Your choices matter. If today's episode was useful to you, please share it with someone who needs it, a fellow teacher, a student, a friend who's curious and a little nervous about what AI means for the world. Leave us a review wherever you listen. It helps more people find us, and every new listener is one more person thinking critically about these questions. You can find show notes, chapter resources, vocabulary guides, and discussion questions from our companion textbook at our website. Links are in the episode description. Next episode, we'll be exploring one of the most important questions at the intersection of learning and technology today. We hope you'll join us. This has been this week's episode of Teaching and Learning with Artificial Intelligence podcast. Have a wonderful week ahead, and we look forward to reconnecting with you next week. Keep thinking, keep questioning, keep learning.